Hello, in this video I want to show you how you can add 3D objects and physics to your phaser game with the package Enable 3D, which I released this week. We create a new phaser game using the project template. Just go and grab this line and put it into your console to clone this repository. Then cd into it and install it, and then open your code editor. Let's just wait while it downloads the packages. At the same time you can just read the documentation. In how to use you find a quick setup. So we will install npm install enable 3D, and then we do npm start. At the same time we can just clean up a bit the project structure. We just want to use one file, keep it simple. Just remove this, it opens the browser. Meanwhile, remove this and simplify the config file. So remove all of this, blah 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 blah. Don't need this. Create a main scene later. Don't need physics. Just clean it up a bit. So then I quickly add a new class called main scene, which extends the phaser scene. Main scene. Okay, then just look if it works. Create. So let's take a look at the browser, and it looks like it works. Okay, cool. So we can get started implementing this. First of all, we include enable 3D and 3D scene. So instead of extending phaser.scene, we extend our scene with scene 3D. Then we make sure we have WebGL as the type. And then we have to wrap our phaser game into enable 3D. Enable 3D. That like so. And when we want to add physics, so we add with physics. The path, I don't have the libraries yet, but I will add it to assets, to the assets folder. I quickly grab those files from the npm folder structure. Enable 3D lib duck, and put it into our public directory. So just verify that it loads this package. Yes, this is loading. So I guess the setup is finished. Now we have to work on our scene. In the init function, we request access to the third dimension. So where's our scene init? Request third dimension. Then the create function, we access the third dimension. Now we can save this and see how it looks. It doesn't show anything. This is completely normal, because we first have to set up our light. We have to add some objects. We have to add the ground and the background and everything you need. But you can, instead of this, just add a warp speed, which will set up a demo scene for you, like so, with a nice ground and grid and lights and background, and this you can drag and drop it around, and with the mouse wheel you can zoom. That's pretty neat. Then let's go back to the browser and see what we have to do next. We can add a box. Where do I need to go here? So, box. This takes an object with the coordinates width and height and so on. And the second object will be the material of this object. So, for example, we use standard material with a random color, like so. Let's see what this does. Well, now we have this object here, the magenta cube. But I want to add physics to it, so we just, instead of third add, we use third.physics.add. Now it should have a physical body, and it will fall to the ground. Cool. We this in magenta, or just cube 1. Let's see, because we want to add another cube, just with the default material, a bit lower, like so. And we call this cube 2. Let's see, they should now collide. Yes, now we add a collision callback. So this dot third dot add dot collide, no, where it is, dot physics dot add dot collider. We pass these two objects, cube 1 and cube 2. Then we have a callback function. Every time this function is called, we console log collision. Unfortunately, the laptop I'm using is pretty slow, so you can't see much here. Just have to wait. Okay, yes, now the collision. So we just remove this. This is how you check collision between two objects. Now you can also check for all collision on one specific object, like cube1 dot on body dot on collision. Then we get a callback function with the other object, which with it is colliding with object, and each object has a default name. Name. Console log will see the name of the other object which it is colliding with. Let's see. It takes again a bit long. Only with the bottom. Oh, we have, this is the magenta cube. Let's take the other cube to see that it is also colliding with the ground, not all. Let's wait. Okay, so I will quickly stop this because if you want to check for certain collision, the ground, you can add names to each object, like name cube 1. This will then override the default name. The ground by default has the name ground. You could just check for the collision with object other object dot name equals to ground, for example, and then you will see you know what it does now. So that's a quick introduction to this. Of course, you can to much more, like adding textures, animations, including 3D characters with their animations. You can add constraints, so you can combine multiple objects. You can do much more. I haven't written the documentation yet, but it is already possible to do so. Maybe if you just check the source code, or you just enter this .third, you will see everything you can do here. For example, in the physics, you can add ground, sphere, box. You can add lights if you get different lights, hemispheric light, and all that kind of stuff. That's just a quick introduction. I hope I can continue to develop it further, and will make great documentations, videos, and examples in the future. Thanks for watching.